this is a worked example on how to verify a trig identity. So I chose this one as the starting example because I wanted to go over a slightly more interesting example than some of the more obvious ones, I should say, that are at the start of the textbook. Um, this looks confusing, I guess, because it has a fraction involved, but it's really not that bad. And I think it highlights some basic first things that you can try when doing a verification of an identity. So what we're going to do is we're simply going to, try and make one side of the equation look like the other. Um, so this fraction, it feels kind of hard to like pull apart. So let's actually work from the other side because we might be able to like see what's going on. And so I'm going to replace the definitions of secant theta and tangent theta with their definitions that include sine and cosine. So if you have your identities memorized or you have the sheet in front of you, you might know that secant of theta is equivalent to 1 over cosine of theta. And then you might also know that tangent of theta is equal to sine of theta over cosine of theta. And just with doing that substitution, it might already be a little bit clear what's going to happen. We can take the numerators and multiply them with the denominators because when we're multiplying fractions, we can multiply across numerators and denominators. And when we combine this into one fraction, we get sine of theta over cosine squared, because there's two of them, theta. And this is one of the cases that lets us verify an identity. We have a, well, sort of trivial equation, right? An identity means whatever value of theta we use, the statement is true. And of course, if I have one side of the equation equaling the other side, I can make theta be whatever I want it to be, and this equation will be true. Um, if you wanted to take this even further, you could sort of, multiply out the cosines and you would get sine theta equals sine of theta, and then you could even divide the sines and get 1 equals 1. Either way, but as soon as you get to this point where your equation is the exact same on both sides, you will then know that, yes, your identity is verified. It works for all the values of theta. Of course, the caveat is if cosine is 0, it's undefined, but anywhere the quantity is defined, this identity is valid. And that is how you verify some basic identities.